In July 1969, the world watched as Neil Armstrong took his first steps on the moon. The Apollo 11 mission ignited imaginations worldwide. We were in a space race with the Soviet Union. Landing on the moon was about national pride and technological prowess. The Apollo missions pushed the boundaries of human knowledge. We studied the lunar surface, brought back samples, and conducted experiments. These missions sparked interest in science and engineering. The legacy of Apollo extends beyond the astronauts who walked on the moon. Technologies developed for Apollo had a profound impact on daily life. From materials science to microelectronics, the echoes of Apollo still resonate. The Apollo missions showed what we can achieve together. Despite Apollo's success, we haven't returned to the moon in over 5 decades. The question is why we haven't established a permanent presence on the moon. The moon holds vast, untapped resources and scientific potential. It's a stepping stone to further exploration of our solar system. So why have we turned our backs on this celestial frontier? The reasons for our delayed return to the moon are complex. Following Apollo, public interest in space exploration waned. The space race ended, and the urgency to maintain dominance diminished. The cost of space exploration is high, and other issues demand resources. In an era of economic uncertainty, space exploration often takes a back seat. Technological challenges of a sustained lunar presence are significant. Unlike Apollo, a sustained presence requires new technologies. Despite these challenges, the dream of returning to the moon is alive. Recent years have seen a resurgence of interest in lunar exploration. New spacefaring nations and private companies are venturing into space. The moon is now seen as a hub for scientific discovery and economic opportunity. International collaboration is key to future lunar missions. The moon is no longer the sole domain of superpowers. Since Apollo, spacecraft technology has advanced significantly. The Saturn V rocket was a marvel of engineering. Today's rockets are designed with reusability in mind. Companies like SpaceX and Blue Origin are pioneering reusable rockets. They aim to make space travel more affordable and accessible. Modern spacecraft are lighter, more fuel-efficient, and equipped with advanced life support systems. The Orion spacecraft is designed for missions beyond the moon. Advances in propulsion technology, like ion propulsion, offer more efficient thrust. Ion propulsion uses electrically charged particles for thrust. This technology holds the key to reaching outer planets. These advancements pave the way for more ambitious lunar missions. Imagine scientists and engineers living and working on the moon. These advancements inspire future generations to push boundaries. The future of space exploration is bright. We are on the cusp of a new era of discovery. The moon is just the beginning. Robotics and automation are indispensable in space exploration. Robotic missions have revolutionized planetary science. Robotic rovers can traverse the lunar surface, collecting data and conducting experiments. These rovers can withstand the harsh lunar environment. They act as scouts, exploring unknown territories. Robotic arms can perform intricate tasks, reducing the need for risky spacewalks. By delegating tasks to robots, astronauts can focus on research. Autonomous spacecraft can orbit the moon, mapping its surface and searching for resources. Data from these missions provide valuable insights. They help identify landing sites and locate resources. Robotics enhance mission safety and efficiency. The role of robotics in lunar exploration is crucial. They pave the way for future human explorers. Establishing a sustained human presence on the moon requires vast resources. Transporting supplies from Earth is costly and complex. In-Situ Resource Utilization, ISRU, focuses on using lunar resources. The discovery of water ice at the lunar poles opens up possibilities. Water can be broken down into hydrogen and oxygen. Oxygen can be used for breathing and hydrogen as rocket fuel. Lunar regolith contains valuable elements for construction and manufacturing. Imagine lunar settlements built using materials mined on the moon. Developing ISRU technologies is crucial for a viable lunar outpost. Harnessing lunar resources reduces the cost of missions. This approach makes lunar exploration more sustainable. It opens up new avenues for scientific discovery. The moon can become a refueling station for deeper space missions. ISRU transforms the moon into a hub for exploration. The future of lunar exploration is promising. Reliable communication and navigation are crucial for lunar missions. Advances in laser communication technology promise faster data transfer. Laser communication offers higher bandwidth than radio waves. This means real-time high-definition video and data from the moon. A dedicated lunar communication and navigation network is essential. Satellites orbiting the moon provide continuous coverage. Advanced navigation technologies enable safe and efficient lunar exploration. Autonomous navigation systems allow robots to plan routes and avoid obstacles. Terrain-relative navigation provides precise positioning. These technologies are essential for scientific research and exploration. They ensure the safety of astronauts on the moon. Communication and navigation advancements are key to future missions. Space exploration is expensive. Developing powerful rockets and sophisticated spacecraft requires significant investment. The Apollo program cost around $280 billion in today's dollars. Technological advancements have led to some cost reductions. Human spaceflight missions are particularly expensive. Ensuring astronaut safety requires sophisticated technologies and training. These high costs pose a challenge to space agencies. Securing funding for ambitious missions requires convincing policymakers. The potential benefits of space exploration must outweigh the costs. Space agencies rely on government funding for exploration goals. The financial investment in space exploration is substantial. The price tag of space exploration is a significant consideration. Space exploration competes for funding with other national priorities. Governments must prioritize spending carefully. Space exploration can take a backseat to more immediate concerns. Public perception of space exploration shapes funding priorities. Maintaining public interest is crucial for securing funding. Political considerations influence space exploration budgets. Changes in government administrations can lead to shifts in funding. This uncertainty makes it challenging to plan long-term missions. Political cycles pose a challenge to the continuity of space programs. Building a skilled workforce and developing technologies require stable funding. Without consistent support, space programs struggle to reach their potential. The cyclical nature of politics affects space exploration. Sustained political will is essential for ambitious missions. Budgetary constraints impact the scope of space exploration. Relying solely on government funding limits space exploration. Alternative funding models and partnerships are crucial. Diversifying funding sources provides financial stability. Collaboration between government agencies and private companies is promising. Private companies bring expertise and resources to space missions. This collaborative approach shares costs and risks. Space tourism and commercial ventures offer new revenue streams. Wealthy individuals are willing to pay for space travel. Commercial activities in space create economic opportunities. International collaboration reduces the financial burden on individual countries. Pooling resources enables more ambitious missions. International cooperation fosters scientific and diplomatic ties. Working together, nations can achieve more in space. Sustainable funding models are essential for long-term exploration. The future of space exploration depends on innovative funding. International collaboration has been a cornerstone of space exploration. The ISS exemplifies what nations can achieve together. It serves as a unique microgravity laboratory for groundbreaking research. Greater international collaboration is essential for sustainable lunar missions. Pooling resources reduces financial burdens, making ambitious missions attainable. Space exploration programs often find themselves at the mercy of shifting political winds. The political landscape, with its changing administrations and budgetary constraints, can significantly impact space exploration. Maintaining commitment requires navigating political complexities and garnering bipartisan support. The Apollo program succeeded due to focused political will and national pride. Replicating this today is challenging without a pressing geopolitical backdrop. Changes in administrations can lead to shifts in funding and program cancellations. Short-term political cycles often clash with the long-term vision required for space exploration. Throughout history, space exploration has often been intertwined with national prestige and geopolitical ambitions. The race to the moon showcased technological prowess and served as a proxy for national strength. Today, space exploration remains a powerful symbol of national ambition and technological advancement. Nations invest heavily in space programs to be seen as global leaders. Success in space can enhance a nation's reputation and foster international partnerships. The pursuit of national prestige in space drives innovation and scientific discovery. However, it can also lead to competition and tension between nations. As more countries develop space capabilities, the potential for friction increases. Competition for resources and strategic locations in space creates both opportunities and challenges. Balancing national ambition and international cooperation is crucial for peaceful exploration. Collaboration and shared goals ensure space remains a domain for scientific discovery and the benefit of all humankind. Public perception shapes space exploration priorities and funding. Engaged public creates a favorable environment for support and resources. The Apollo missions captivated the world's imagination. Neil Armstrong's moonwalk inspired generations. Public enthusiasm translated into support for NASA. Maintaining interest is challenging without a compelling narrative. Economic hardship can reduce support for space exploration. Communicating space exploration's value is crucial. Highlighting benefits maintains public interest. Educating and inspiring future generations is essential. In the realm of space exploration, international cooperation and competition are often intertwined, shaping the landscape of possibilities and influencing the trajectory of missions. While competition can drive innovation, technological advancements, and the pursuit of ambitious goals, cooperation is essential for sharing the costs, risks, and rewards of exploring the cosmos, fostering scientific progress, and ensuring that space remains a domain for peaceful collaboration. The International Space Station, a testament to the power of international cooperation, stands as a shining example of what can be achieved when nations pool their resources, expertise, and aspirations. The ISS has served as a unique microgravity laboratory, enabling scientists from around the world to conduct groundbreaking research in a multitude of disciplines, fostering international collaboration and demonstrating the potential for peaceful cooperation in space. However, the increasing number of actors in space, including both national space agencies and private companies, introduces new complexities to the landscape of international cooperation and competition. The pursuit of national interests, commercial opportunities, and strategic advantages in space can create both opportunities and challenges for collaboration, requiring careful diplomacy, transparency, and a commitment to shared goals to ensure that space remains a domain for peaceful exploration and scientific discovery. Finding a balance between competition and cooperation is crucial for the future of space exploration. While competition can drive innovation and push the boundaries of what's possible, cooperation is essential for addressing shared challenges, pooling resources, and ensuring that the benefits of space exploration are accessible to all of humanity. Fostering a spirit of collaboration, transparency, and mutual respect among all spacefaring nations and entities is paramount for realizing the full potential of space exploration for the benefit of generations to come. NASA's Artemis program marks a bold resurgence in lunar exploration, aiming to establish a sustained human presence on the moon and push the boundaries of human exploration and scientific discovery. Named after the Greek goddess of the moon, Artemis represents a new chapter in our lunar odyssey. Unlike Apollo, Artemis envisions a long-term presence on the moon, a stepping stone to Mars. The Space Launch System and Orion spacecraft form the backbone of NASA's human spaceflight ambitions. Artemis is about more than just powerful rockets and advanced spacecraft. It's about developing the technologies, infrastructure, and partnerships needed for a sustainable human presence on the moon. This includes building a lunar gateway, a space station in orbit around the moon. The gateway will be a testament to international collaboration. Artemis is about unlocking the mysteries of our celestial neighbor and inspiring future generations. The program promises groundbreaking scientific discoveries and a new era of human exploration. International collaboration is key to our success in space exploration. No single nation can overcome the challenges alone. Pooling resources and expertise, we achieve more together. The Artemis Accords highlight this commitment to peaceful exploration. ESA contributes vital components like the European Service Module. ESA is also developing the Lunar Gateway's IHAB module. Collaboration extends to shared scientific goals and astronaut training. Other nations are making significant strides in lunar exploration. China has landed rovers and plans to send astronauts to the moon. India discovered water ice on the moon with its Chandrayaan program. These efforts highlight the global interest in lunar exploration. It's a testament to the unifying power of scientific discovery. Together, we can unlock the secrets of the moon and become a multi-planetary species. While government agencies like NASA have traditionally led the charge in space exploration, private industry is playing an increasingly prominent role, bringing innovation, efficiency, and a new perspective to the quest to return to the moon. SpaceX, founded by Elon Musk, has revolutionized the space industry with reusable rockets, significantly reducing costs. Blue Origin, founded by Jeff Bezos, focuses on reusable launch vehicles and space tourism. These private ventures complement and collaborate with government agencies, fostering a dynamic space ecosystem. This synergy accelerates space exploration, making our return to the moon a sustainable endeavor. The ongoing efforts to return to the moon extend beyond simply getting there. They're about laying the groundwork for a sustainable human presence. This involves developing technologies that enable us to live and work on the moon, utilize its resources, and conduct groundbreaking scientific research. One crucial area of focus is In-Situ resource utilization, or ISRU, using resources found on the moon to reduce our reliance on Earth-based supplies. The discovery of water ice at the lunar poles has opened up exciting possibilities, providing breathable air and rocket fuel. Harnessing lunar resources will be essential for making a lunar outpost economically viable and sustainable. Three-dimensional printing technologies are also being explored for their potential to construct habitats and other infrastructure on the moon. This innovative approach could significantly reduce the amount of material that needs to be transported from Earth. The moon offers a unique environment for scientific research, with its low gravity, absence of an atmosphere, and pristine geological record. Scientists are eager to study the moon's geology, search for signs of past life, and conduct experiments in astrophysics, materials, science, and human physiology. The knowledge gained from these lunar studies will deepen our understanding of the moon and our solar system. The ongoing efforts to return to the moon represent a bold investment in our future, a testament to our collective ingenuity. As we venture back to our celestial neighbor, we carry with us the dreams of generations past, and the promise of a future where humanity's reach extends beyond Earth. Imagine a future where the moon is no longer a desolate, uninhabited orb, but a bustling hub of human activity, a testament to international collaboration and our collective desire to explore the cosmos. The Moon Village concept, championed by the European Space Agency, represents a paradigm shift in space exploration. Moving away from competition towards cooperation, it envisions a network of interconnected modules and research facilities. Different countries contribute their unique expertise, creating a truly international community on the lunar surface. Imagine scientists from around the world working side by side, conducting groundbreaking research. The Moon Village represents a shared vision for the future, embracing the challenges and opportunities of space exploration together. As we establish a sustained human presence on the moon, the focus will shift from simply surviving to thriving, from mere exploration to resource utilization and economic development. The moon, rich in valuable resources that are scarce on Earth, holds the potential to fuel a new era of space industrialization, unlocking economic opportunities and supporting humanity's expansion into the solar system. One of the most sought-after resources on the moon is helium-3, a rare isotope of helium that is virtually non-existent on Earth but abundant in lunar regolith. Helium-3 is considered a potential fuel source for fusion reactors, offering a clean and virtually limitless source of energy. Establishing lunar mining operations to extract helium-3 could revolutionize energy production, providing a sustainable alternative to fossil fuels and addressing some of the world's most pressing energy challenges. The moon is also rich in rare earth elements, essential components in electronics, batteries, and other high-tech devices. Establishing lunar mining and processing facilities for these elements could alleviate supply chain vulnerabilities on Earth, reduce our reliance on environmentally damaging mining practices, and support the growing demand for these critical materials. Furthermore, the moon's low gravity and lack of an atmosphere make it an ideal location for manufacturing and assembly operations. Products manufactured in space would benefit from the unique conditions of microgravity, potentially leading to innovations in materials science, pharmaceuticals, and other fields. Imagine a future where spacecraft components are manufactured on the moon, utilizing lunar resources and reducing the need to transport heavy materials from Earth. The moon, a celestial time capsule preserving billions of years of cosmic history, offers a unique and invaluable laboratory for scientific research, promising to unlock secrets about the formation of our solar system, the early universe, and even the origins of life itself. Establishing a permanent scientific outpost on the moon would usher in a new era of discovery, enabling researchers to conduct experiments and observations that would be impossible to replicate on Earth. The far side of the moon, permanently shielded from Earth's radio noise, provides an ideal location for radio astronomy. A radio telescope on the lunar far side would be able to observe the universe at wavelengths that are blocked by Earth's atmosphere, offering unprecedented views of the early universe and potentially even detecting faint signals from distant civilizations. The moon's surface, scarred by billions of years of meteorite impacts, holds a wealth of information about the history of our solar system. By studying lunar craters, scientists can learn about the frequency and size of impacts, providing insights into the evolution of the Earth-Moon system and the potential threats posed by near-Earth objects. Furthermore, the moon's low gravity and absence of an atmosphere make it an ideal location for conducting experiments in fundamental physics. Scientists could study the behavior of matter in microgravity, test theories of gravity, and search for evidence of dark matter and dark energy, potentially revolutionizing our understanding of the universe. The moon, our closest celestial neighbor, represents not just a destination in itself, but a crucial stepping stone on humanity's journey to become a multiplanetary species. By establishing a sustained human presence on the moon, we can develop and test the technologies, infrastructure, and expertise needed for even bolder missions to Mars and beyond, transforming science fiction into scientific reality. The technologies developed for lunar exploration, such as life support systems, radiation shielding, and in-situ resource utilization, will be directly applicable to future missions to Mars. The challenges of surviving and thriving on the moon will provide invaluable lessons for designing habitats, growing food, and managing resources on the red planet. Moreover, the moon can serve as a launch pad for missions deeper into the solar system. The lower gravity of the moon compared to Earth means that it requires less fuel to launch spacecraft from the lunar surface. This could significantly reduce the cost and complexity of future missions to Mars and beyond, opening up new frontiers for exploration and scientific discovery. The journey to Mars will be long and challenging, requiring international collaboration, technological innovation, and a shared commitment to pushing the boundaries of human ingenuity. But by establishing a foothold on the moon, we will be one giant leap closer to achieving this audacious dream, paving the way for a future where humanity becomes a spacefaring civilization, exploring the cosmos and unlocking its mysteries. As we stand at the precipice of a new era of lunar exploration, it's crucial to remember why returning to the moon is not just a whimsical pursuit, but a necessary step in humanity's evolution. The moon offers a treasure trove of scientific knowledge and resources crucial for our long-term survival and technological advancement. By studying the moon's geology, we can piece together the history of our planet and gain insights into the processes that shaped our cosmic neighborhood. The discovery of water ice at the lunar poles has opened up tantalizing possibilities for resource utilization, potentially fueling future missions deeper into space and providing a testing ground for technologies that could one day sustain human life on other planets. The technological advancements driven by lunar exploration will have far-reaching benefits here on Earth. From new materials to advanced robotics, the technologies developed for lunar missions will find applications in fields as diverse as medicine, manufacturing, and energy production. Moreover, the challenges of living and working in the harsh environment of space will foster innovation, pushing the boundaries of human ingenuity and inspiring future generations to pursue careers in science, technology, engineering, and mathematics. The pursuit of lunar exploration is not without its critics, who argue that the resources would be better spent addressing more immediate problems here on Earth. While these concerns are valid, we must remember that investing in space exploration is not a zero-sum game. The advancements made in pursuit of seemingly distant goals often have unexpected and transformative benefits that ripple through society, improving our lives in countless ways. Moreover, the challenges facing humanity such as climate change, resource depletion, and the threat of asteroid impacts require a long-term perspective and a willingness to invest in solutions that may not yield immediate results, but are essential for our survival as a species. Returning to the moon is not simply about reliving past glories. It's about embracing a future where humanity becomes a multi-planetary species. The moon represents a crucial stepping stone on this journey. The journey will be fraught with challenges, requiring international collaboration. But the rewards make this endeavor essential for humanity's future. Imagine a future where lunar industries provide clean energy and valuable resources. This vision of the future is within our grasp. The technologies exist, and the human spirit is ready for the challenge. What's needed now is the collective will to embrace this next giant leap. By returning to the moon, we gain a new perspective on our place in the cosmos. The lessons learned will help us address challenges on Earth. The time to act is now. Let us create a brighter future, reaching for the stars and rediscovering our world.